So this is a machine learning project that I've done, and it focuses more on the machine line and the pipeline of modular coding. So the data set is around it has around 600,000 plus rows of data points. So these are some of the columns, or you can call it as features. So we have status, bedroom, the number of bed, the number of bathrooms, the size of the land in terms of acres, and we have which city the property is from, which state the property is from, and the size in terms of square feet, and the price in terms of dollars. So this is basically about the data set, and we have close to, I believe, 12 different states, and at around probably 500 plus cities altogether. Let me just show you quickly the prediction. So we are running the prediction a local host here. So once we click on it, we'll be directed to the prediction point, which uses based on Flask. And let's just take the data from here. Let's just take an example from here. I'll just go with, yeah, this is random. We can do any sort of prediction. I'll just go with Connecticut and maybe this world and click on OK. So we have data that is filtered based on city and state. Reason why it is, it's much easier to choose. And this is the number of bedrooms. So let's just put that as 8, and the bathrooms to be 3. Then the acres are land size in terms of acres, and the house around 2341 square feet, 2341 Connecticut and Griswold. So we get this. There's a predicted price. As you can see, it goes well with what is here. We can also slightly manipulate the data. For example, we can take it as zero point 0.3 acres, and we can, just do that, and we'll relatively get the pricing. So you can see the pricing has increased. Earlier it was like around $234,000. Right now you can see that it is around $285,000. So you can pretty much choose from any of these, states. Let's go with random. Let's just change the number of bedrooms to 4, and the bathrooms to, yeah, 3 should work, and lot size around 1.6, and size to be around 4,000 square feet. Pretty we should get. So this is the kind of, you'll be able to predict pricing based on the features. So this is the project that which has been which I worked on. So let's get into the details of how this project was done and what are the process that was involved in the kind of libraries that were used in the machine learning and the machine learning algorithms, and the overall process. So let me close this and let's go through the data first. So we know that we have these many columns, around 6 columns in terms of dependent value, independent value or independent features. So what happens is the price is going to be predicted based on the house size, state, city, acre size, number of bedroom and number of bathrooms, right? So these become the independent features, and price is our target value or target feature here. So this becomes a dependent feature or dependent value. So the price is dependent on all these other columns. And when we look at the data, how it is spread, we can see that the data, 80% plus of the data is in the regions of New York, in New York, Massachusetts, at Connecticut, and all of the place over here, which is, like it includes Pennsylvania, New Jersey, and so on. So this is how the data is spread in terms of, like the overall. Uh, so yeah, you can see almost 80% of the data in the East region itself. So, and also if you look how the data is spread, there are certain outliers you can see here, which are very extreme. So what we can do is we can filter it out by using the filter here. So we can see here almost the density is up to, let's just take 12 or 10 million at this point, in terms of, not 10 million, sorry, in terms of 40,000 square feet has a barrier. So let's apply that, and you can see the spread of the data. And also let's limit the pricing. And by the way, the x-axis represents the size of the house in terms of square feet, and the y-axis represents the price in terms of millions. So let's just take somewhere around here to see the spread. Yeah, let's just take around maybe 20 million as a filter point. Yeah, so we can see how the data is spread, and even in terms of the square feet, you can understand that majority of the data is within the 10,000 bracket. So let's we can further change it 10,000. Yes, we can see how the data is spread here in terms of like the price as well as the number of square feet. So our data is quite spread, and it's quite vivid. So it so a sort of classification would work on top of regression, and the models could be chosen accordingly. We can also use filters again. Yes, so this is the data for Connecticut, and you can see how it's spread. There is definitely some sort of a correlation that can be observed, and there is a density that can be observed. So this is again for Delaware. So New Jersey, again there is a positive correlation as a price, as the square feet increases, there is a price increase up to a certain density point of, I think, around 1 million in this case in terms of just New Jersey. So you can see after which there's a slightly exponential change in terms of the price increasing even despite it being less in terms of square feet. So there could be various reasons for that, such as the luxury point of a property and so on. So this is the basic understanding of your data, and you can see, especially in New York, even properties having around just 700 square feet are around 1.8 million, 2 million, and so on. So there is the if the luxury of the property is higher, if the property is much more luxury, we can say that there is increase in price, and the correlation kind of fades away. So it is kind of important to have a classifier or classification in terms of the data. Moving on, you can see visualize like there's a tree map, so we can see that New York in the data, New York is the highest. We have around 40% of the data that is coming just from the New York, or 35 to 40%. And we also have New York, Massachusetts, New Jersey, Connecticut. These four regions alone almost take up like 75% of the data. We can see only this Vermont, Maine, New Hampshire, and so on. These a small portion, whereas the other New York, Massachusetts, New Jersey, and Connecticut just accounts for around 75% of the overall data. And also this is all like in terms of this is a matrix chart which represents different numerical values like the average size of the house, the average pricing in different states, and further if we go in depth we can see each city's their particular value and in terms of the number of um, bathrooms, bedrooms that are present on an average, respectively. So this is all basic understanding of the data. We are not going to go get in depth with understanding the data, or this is not a data analytics based sort of a project. So I'm just that's the reason I'm keeping it very minimum. And you can see that this is how the average price varies in terms of city wise, you can say. So and you can see this is probably the top 30, and within the top 30 we can see that New York is has the most highest average price. So the cities within New York have on an average have higher price as compared to other cities in other states. We can see followed by Massachusetts and followed by Connecticut. So this it gives us a glimpse that New York has one of the highest, followed by Connecticut, Massachusetts, and uh, other parts, especially the ones that are on the east, have seems to have more data as well as in terms of the average pricing seems to be quite varied as per the scattered plot that we just saw. Now let's get into understanding how the project has been built in terms of pipeline and let's just quickly go through like in terms of understanding the data a little bit more. And yeah, we know that this is the kind of data set we have, and this is basically using NumPy, Pandas, Seaborn, Matplotlib libraries within the Pandas. So this is our data set. Now it's converted into a data frame right here. So we are looking at the different type of data that is within the data set. So this is an object, or we can say it's a categorical value. So the two types of values, what we can see is we have categorical value, which is a string. Like you have city name or state name. Those are not numerical numbers. Those are categorical values or categorical. Yes, so they're categorical values. And we have numerical values such as bed, bath, acre, size and house size, price, and so on. And we can see we have a float value which is like in terms of decimal, that is acres. And this was initially float, but I've converted it to int, the size of house or the number of bed, because we don't want a decimal point over there. Number of bed is going to be 2, 3, 4, a whole number. And yeah, these are the unique states within the data, and each state, for example, New York has around 1,442 unique city, and respectively every state has its own number of unique cities, and that's the kind of data which is shown here. So we can say 80% of the data comes from here in this particular data set. So moving on. Yes, so there are no null values. There is no missing values in this particular data set. So this is basically just going through the data and understanding, and we are just trying to split the data for training and testing purpose. So whatever the machine learning model, we have a training data where it is trained, and we have a testing data where it is tested to understand the accuracy. For example, we have, let's say, 100 data. In that, 70 data is used for training the machine learning model, and the 30 data or 20 data, whatever we choose, that'll be used for testing. And once we test, we understand how accurately we are getting the results in terms of either percentage or different metrics such as mean square error, especially in terms of regression, mean square error, or uh, we have a mean absolute error and R2 score. Those measure the value those measure the accuracy of how the model is performing. And we are also going to use something called label encoder. What it does is now, in terms of machine learning, we cannot use categorical values such as the city and state. So we are going to convert it to a number that is more like a ID number, you can say. So you will see that these are converted to different ID numbers. And yes, so that is basically what label encoding does. And moving on, we are going to split the data. We are going to try out different machine learning models once the basic training and splitting is basic splitting is done for training and testing. So these are some of the models that we can use. We can use since our data has categorical values, and this is a regression problem. Like we are not trying to classify, like uh, we are trying to predict a price. We are trying to predict a number based on the numerical value as well as the categorical value, which is city and state. So this becomes a classification plus a regression problem. So classification is something like you're classifying, for example, let's say you have reviews of something based on the number of stars or 1 to 5. So it is a classification if the customer has reviewed you 3, 4, 5. Or the better example would be, let's say you're trying to sell someone an insurance. It's a very basic example. So there are two types of customers: who will buy, who will not buy. It is determined based on different factors, but basically we are trying to classify whether the customer is going to buy or the customer is not going to buy in terms of the likelihood. So, and also we can give one more example as, let's say when you talk about diamond, there are different colors of diamond again. So let's say we have five categories like around white or light yellow or light blue. So all these are being categorized. So that is classification. And right now what we are doing is we are trying to predict the price. Now when we're trying to predict the price, it could be more like we have uh, the numerical values, that is, for example, the square feet of the house, the square feet or size of the land, or number of bedrooms and bathrooms. So that will become a regression problem if there are only numerical values. Now since we have state and city, which is a classification, a categorical variables, and we also have numerical values which holds a value, we are going to use a classification plus regression sort of a machine learning algorithm. So we have a decision tree regressor, random forest regressor, and gradient boosting algorithms to which can be used as for training. So this is what we are going to use something called grid search CV, which depending on the model, it is going to try out different parameters. You can see these are some of the parameters that has been given within the project and within the model for this particular XGBoost model. So we have XGBoost, and these are the parameters for XGBoost to get the most optimized results, you can say. So this grid search CV goes through and searches which is the best parameters, and it returns you the best parameters after trying out several iterations. So that is pretty much it, what we are going to do. And then after this, we are going to predict, which I'll be showing you. And this is basically the pipeline. So we have data validation first. So what we are going to do is whenever we get batch files, we are going to validate it, because if there are missing columns or if the data is not clear, we are going to reject it. So basically we are going to segregate it into two directories. One is the valid data files and the other one is invalid data files. So whatever the valid data file will go through the second pipe step in the pipeline, which is data ingestion. So in the data ingestion, we are going to whatever the data that was validated, we are going to merge all the data, and we are going to combine it and convert it into a data frame. So once after it's converted to a data frame, in the data pre-processing, we are going to handle such as handling missing values or removing unnecessary columns. For example, we have, in our case, we have to delete or drop the status column, as we know. So yeah, we know that this is not useful, so we have to drop that. And we also have to convert state and city, which is a string value, into a numerical value. As we can see this is a string, so New York is a words, you can say. So we have to convert that into numerical identity, so for which data transformation, and then we are going to split the data, as I mentioned, for training and testing purpose. And then we are going to train the model, we are going to see which is the best parameter, and we are going to also use the best model that gave us the most accuracy for prediction. And we will save that model in a directory, and that model will be accessed for prediction. So before we get into the prediction, we have the next step, which is evaluation. Once we have these model that has been registered, we are going to test it with the test data, right? So we initially, if you remember, we split the data into training data and testing data. So we are going to use prediction point. The model that was trained will be used to predict the test data, and the test data accuracy will be calculated. And different parameters, as I mentioned, such as mean square error, mean absolute error, R2 score, will be used to validate how accurate the model is, or how good it is performing. And then after, once the model is validated, we are going to use it for prediction using libraries such as Flask. So where we have the prediction point which is ready. And right now, if you look at the endpoint, which was here, right? So it is in terms of letters here, or you can say words. Like you can see, this is not in terms of ID. So this keywords, for example, we have new hemisphere, and again, this is from the prediction. We have the words that needs to be converted into, it needs to be converted into this kind of ID again, right? Even for prediction, the data needs to be converted basically. So we are going to use data transformation, or using the label encoder as mentioned, to convert from a word to a numerical letter. And after which we are going to locally host the Flask server, as you can see here. And further, this is the last step for prediction in this particular local host. After this, it is going to be packaged in maybe using Dockers and different parameters such as resource groups, instances, and the kind of virtual machines that is required in order to run this prediction point is, allocated in the cloud. For example, Google Cloud, or Azure Cloud, or even AWS. And then these pipelines and models are going to be packed and registered, and it's going to be running. And once it's registered, we are going to get the endpoint API from the cloud. So the cloud will give us an API endpoint, which is going to be used for the backend and the real time, the real time data that is coming from the user using the website, or you know whatever application it is. So this is about the pipeline. So let's get into looking at the project. So let me start it again. So here, if you look at it right now, let me delete all this. It's So this is deleted, and even ingested data. Yeah. So now I'm going to go to the data source. So this is the data, that is the batch data what we have. And if you go here, this is basically the repository, or this folder where, so basically one more thing is, this whole project right now is stored in the GitHub repository. So from there, we are doing the CI/CD, continuous integration and continuous development, and we are saving it in the GitHub repository. So let's put the data here. So initially the data will be batch, will be given in a batch in, and we are storing it in data for ML. So we can see the data files are here, and it is the same, the data is in the same format as what we have seen previously. So we have like status, bed, bath, and so on. And this data right now, if you look at this project, we have different files. So we have the first one, we are following the same pipeline as what was explained here. So first will be the data validation. So if you look at it here, we have the data validation here. So let's run that quickly. So, and one more thing before we get into this, I just quickly wanted to tell you there are certain libraries that are required. These are some of the libraries like scikit-learn and catbos, pandas, numpy, and so on. So basically, this needs to be installed, and this is in a Python 3.9 version, which is running and which is suitable for all the libraries that are installed. And yeah, that is pretty much I wanted to tell. And yes, as we go, we will see that we have a steps folder here, and we have a, like the data validation file. So when we run this data validation, or let me just quickly explain the code first. What is happening here? Let me go through it very quickly. So we have imported the logging, all of that. We have imported, and we have the data validation. So there is the path where the data files are stored. In this case, it's the data for ML. So this will be passed here, and all, like if any file that ends with .csv, which is the data type, that will be like it will be read, which will be opened as a data frame, and further it will be checked if these columns exist. So if these columns exist, that means that the CSV file is good. So if columns, the current CV columns match the standard, so this is basically the standard columns. And if you see the current CSV was here, the data, the file which was opened was here. So basically it's going to check if the columns are correct, and then it's going to move it to a folder called data valid data. So valid data is here, this particular folder. If not, if the columns are not matching as per the standard columns that is expected, it will move to the invalid data folder. So that is what this is going to do, and let's run it quickly and see. Data. Yeah, as you can see, we got a return saying that your data CSV files are segregated, check valid and invalid data folders. So if you check at valid data folder, you'll see all the data that was in that data for ML folder has passed, or it's considered as valid because the columns were correct, and now it's in the valid data folder. So next thing will be, next step of the process would be data ingestion. So when you go to data ingestion, it's right here. So if you look here, whatever the data that is in the valid data folder, that the path of that is passed here in this particular function of data ingestion, and we will have every file in that appended to a list and then merged as a single file. And if there is some sort of error, we're going to get the log here. And whatever has been ingested, it will be named as ingested data, and it will be moved to this folder called ingested data. So this is the ingested data folder. So if the data, once it's merged, it will be sent to this particular folder. And that is pretty much about this particular thing. So let's run that. So yeah, you can see data ingested. So if we look at, we have got the data that is ingested, right? And moving on, the next step would be data pre-processing. So let's go into that deep. So data pre-processing, this is the folder. So again, we have the basic log setup and whatever libraries that are necessary has been imported. So data transformation. So first thing first, the columns with float value in terms of decimal is converted into integer values. Then the next step is whatever the columns are unnecessary. For example, the status column is unnecessary, that is going to be deleted. And whatever categorical values we had, like the state and the city, that is going to be converted into an integer, which uses something called label encoder. And now one more thing is, when we are trying to predict the data, whatever the data is coming for prediction, even that will have state and city as text letters, right? So that also needs to be converted, for which we are trying to save this encoder, which converted as a pickle file, so that we can use this and later and convert it, so that the id what is you what it converted in the data pre-processing and the data that is from the prediction that is going to be converted, that id both have to match. For example, you have state which is New York, which will be given id 2, and let's say the state New York, in the data that is coming from prediction, if that is given as the 3, the id, so 2 and 3 are not same, so you're going to get a wrong prediction. So the ids of the state and city have to match both in data pre-processing as well as the data that is coming from the prediction. So, and on next we are going to split the data into test and train data. So this is basically the test data, and this is basically the this is basically the train data, and the test what is mentioned is the train data. So it's going to be a test size of 0.2. 20% of the data is going to be used for testing, 80% of the data is going to be used for the training. So that is pretty much it, and let's just run this as well. So yeah, it's done. You can see that we got the data, and you can see the number of rows have been decreased, and there's supposed to be 7 columns, it's reduced to 6. So one is going to be used for the prediction. So you can for the target value, so we can see this has only one column. Yeah, this is just one column because it doesn't have into 6 as how you see it here, right? So this is one column. So the test and train data have been split. Now the next step of the process is training the model, right? So let's do that training. So yeah, let's go through this quickly. And we have again different libraries that are imported, and logging is imported. And we have the model training class here. So as I mentioned earlier, grid search CV is used, and to find the best parameters for different machine learning algorithms. So right now, to keep it simple, we are only going to use XGB regressor and decision tree regressor. But as I mentioned, we can use other models as well to check the accuracy. Since it's a bit time consuming, I've used only XGB and decision tree regressor. So initially, it's going to these are some of the parameters that are being given, passed on, and these grid search CV is going to implicate it on decision tree regressor model, and further we are going to fit it and see here, and then we are going to we are going to get back the best parameters and the best code what was given. So this is basically what we'll get, and we are going to put it in a list. So now we are going, it's already in a list, and we are going to get the minimum of the MSC in terms of, so whenever the accuracy is measured, it has the MSC or R2. These are some of the metrics that have to be minimum, which would indicate the model is performing good. So we are going to get the best model from within this list, and it's compared and it's retrieved. So this again, if we are passing it here, we are going to pass these parameters, and we are going to, it is going to check. So out of this, in the list of whatever the models were logged, only one is going to be best, one is going to be minimum. So that will be passed on here, that model. So that model has a name. So if the name is decision tree or whatever, we are going to use the parameters and use the, the best params, and you'll use it to basically train it here. And once the model, machine learning model is trained, whatever was the best, then we are going to save it in a particular folder which is called model. So model.pickle. So here the model will be saved here. So you can already see the city and state model is saved from the data pre-processing which we did. So anyway, this is pretty much it about here about the model training. So let's go ahead and train that. So now the model will be trained. So once the model is actually trained, right now it's still happening, we'll see a model.pickle that will come up here. So yeah, we got the model.pickle. So now it means the trained model, the machine learning model, is stored in this particular pickle file. So the next step in the pipeline is the evaluation. So let's get into the evaluation. So here it's quite simple. So whatever the model that we saved here, which is the model.pickle, that will be loaded here, it will be open. And then the same thing with the help of X-test and the Y-test, which is the testing data, will be used to get the scores and different metrics of accuracy. So in this case, it's score, and here we have the mean square error. So here you can see whatever is the tested value that is got in terms of y prediction. So this is basically the predicted values which is compared with the already existing testing data, and that's how it's compared. So for example, whatever we calculated, is it going is it matching with the data that is there? So that is what it compares, and that's where we get to know how accurate the model is. So these are some of the other metrics. As I mentioned, R2 score is one more, and root mean square error. So that is basically used to calculate the accuracy, and this is basically that it's going from one function to other here. So that's basically what has been here. So let's run this as well. So yeah, we got the scores here. If you look at it, the score here is around 8.89, or it represents around like 89% accuracy in a way. And these are mean square error and root mean square error and all of that. So we can say 89.89 is a pretty good score. So it's out of a total of 1. So 0.89 out of 1 is pretty good, and the accuracy seems to be pretty good. So this is a model that is good for using for prediction. So we will next in the pipeline is nothing but the final one, which is prediction. So here let's get into the prediction. So again, some of the libraries are imported, and now you can see something called Flask is used here. It is used for a local host, which means whatever we are going to use here for prediction, it is run within the local computer itself, and it will give you a URL where if you click in, it'll open a web page, and you can put in your input values and you'll get the prediction. So we are loading the model dot pickle, which is here, which is the machine learning model details along with its parameters, which is stored in the pickle file. And the next one is city pickle. So this is used for, like right now you're going to get some data. Like here, you're going to get this particular names as I mentioned, right? So that has to be changed to number IDs for the machine learning algorithms, because yeah, so that will be that needs to be transformed. So the city and state pickle which we got from the data processing pre-processing step now will be used here for the data that is going to be coming as an input, and it'll be the state name will get converted to a numerical value for prediction to run the machine learning algorithm. So we have all the states and all the cities which is saved in terms of a dictionary here, as you can see. So this is basically calling the Flask app, as you can see, and this is providing a dictionary of city and state. So each state name will have all the cities within a list. So this is the whole thing here. And now once we have all this, so you basically have an index which is like a index.html. So it's the HTML file which is here. So here you have all the numbers. I mean, you have all the input values in terms of the front end, which is the web dev. So whatever you're seeing here, there's an HTML that has been scripted here, and then you have a results page. So after you click predict, you are going to see the prediction in a different sort of a page, right? So that is where the result HTML script is written. And now this is a predict. So we are using a request method, and we are providing these values here like respectively as we know what is in our input. And further the model is which was loaded is used for prediction. You can see here the model, the data that will come from here, especially with this categorical value city and state, will be transformed as mentioned using the state and city pickle files which was loaded. And now once it's the prediction is done, so here is the prediction. It is passed in terms of a list or an umpire array, and then you have the result file giving out returning the prediction. So that is pretty much it about this. To run this, let's do the same. Let's call it out, and you got the local host, the HTTP link, and once you click on it you are going to be here. Let me show you again. Once we click on it here, we are going to be given here, and as we showed initially, we can use different parameters in order to just predict our value. And this could be next, it'll be deployed in the cloud. After we package this, it'll be stored in a repository within the cloud. For example, we have the Azure has its own repository, and whatever changes we do, we can use the the Git version control to update the changes within the repository that is within the cloud, such as Azure, uh, GCP, and so on, which is called, the overall process is called like continuous development and continuous integration, CI/CD. And yes, so whatever using the different virtual machines and the different resources and registering the model, the machine learning model, we will get a real-time endpoint API which will be used in the backend for prediction. So yeah, to cover it up, to finalize, to that is pretty much about this particular project what we have gone through so far. So yeah, that's it. Thank you.